All right, so now we're going to cover questions 10, 11, 12, and 13, which are solving exponential equations and logarithmic equations. So you can see this one right here, question 10, just says solve for x, and we have 4 times e to the power of 3x minus 7 is equal to 20. So this is not in the correct form for solving with a logarithm until we get rid of this 4. So we got to get rid of this 4 at the beginning. So we're going to divide by 4 on both sides. That's going to cancel the 4 on the left. We're going to have e to the power of 3x minus 7 is equal to 20 over 4, which is 5. So that's equal to 5. And so now, in order to cancel this e here, we're going to have to take the natural log of both sides. So we'll do the natural log. Well, let me rewrite this. So we'll do the natural log of the left, which is natural log of e to the power of 3x minus 7 minus, or equals, sorry, the natural log of 5. On the left, we're going to cancel the natural log of e. It's going to bring down the 3x minus 7. That's equal to the natural log of 5. We're going to add 7 to both sides. And now we have 3x is equal to the natural log of 5 plus 7. Now we just divide by 3 to solve for x. Divide by 3. And we get x is equal to the natural log of 5 plus 7 all over 3, which we can key into the calculator. So we'll do the natural log of 5, close parenthesis, then we'll do plus 7, and we will, I'm going to press enter, and then I'm going to take that answer and I'm going to divide it by 3. And that's going to give us 2.8698, which would actually be 2.87. Now, I want to show you why I did this. I was concerned that if I had keyed in natural log of 5 and then plus 7, that if I hit the divided by button, see, it would only put the 7 over the 3, not the whole thing. Now, I could circumvent that by doing natural log of 5 divided by 3, and then I could go back up to the numerator and then add the 7. Oops. Add the 7, and then I should get the same answer. Sure enough, 2.8698. So this 8 is going to make this 9 a 10, which is going to make the 6 a 7, and the 9 a 0. So really it's 2.87 is our answer. Okay. So x is 2.87. Okay. Now we'll try question 11. All right, here we are. Question 11, we're going to solve for x again. This time we have 7 to the power of 2x minus 5. This is, and it's equal to 200. This is already in the correct form. We don't have anything on the front that needs to be divided out, so we can just jump right in with a logarithm. We want to cancel this base of 7, so we're going to do log base 7 of both sides. So do log base 7 of 7 to the power of 2x minus 5 is equal to log base 7 of 200. Okay. On the left side, we're going to cancel the log base 7 and the base of 7, and we're just going to bring down the 2x minus 5. So we have 2x minus 5 is equal to log base 7 of 200. Then we're going to add 5 to both sides to cancel the minus 5 on the left. So we get 2x is equal to log base 7 of 200 plus 5. And now we're going to divide by 2 on both sides, and that's going to cancel the 2 on the left, leaving the x by itself. So we get x is equal to log base 7 of 200 plus 5 over 2. Now, we can't leave this as log base 7 of 200. Some calculators, you can key that in, but we're going to change it. We're going to use a change of base to turn log base 7 of 200 into the natural log of 200 over the natural log of 7. And then to that, we'll do our plus 5, and then we'll put the whole thing over 2. So I want to remind you that the change of base formula, changing log base 7 of 200, would make it the natural log of 200 divided by the natural log of 7. So we can key this whole thing into the calculator. So we will do the natural log of 200 divided by the natural log of 7. Now we need that denominator to have the 2. So I'm going to come out of here and I'm going to hit divided by, and then I'm going to put the 2 down here. Then I'm going to go back up to the numerator and I'm going to do our plus 5. You don't have to do the whole thing as one calculation. You can do them as separate calculations and then put them all together. But I want to try and do them all at once. Then I hit execute and I get 3.861. 3.861. So x is 3.861. Okay, that's number 11. Now let's try question 12. Okay, question 12 also says solve for x, only this time it's a logarithmic equation. It's a natural log. So we have the natural log of 9x plus 11 is equal to 5. And this is in the correct form for us to solve a logarithmic equation. And the first thing we're going to do is we're going to create a base of e, and we're going to do e to the power of this whole thing, natural log of 9x plus 11. So e to the power of natural log 9x plus 11. And then we'll set that equal to, now we need e, another e to the power of the other side of the equation, which is 5. Okay? And now this e to the power of natural log cancels out, and all we have left is 9x plus 11. So we'll bring down the 9x plus 11. That's equal to e to the 5th power. Now we'll subtract 11 from both sides. Now we have 9x is equal to e to the 5th power minus 11. And now we'll divide by 9 on both sides, cancel, and we'll have x is equal to e to the 5th power minus 11 quantity divided by 9, which we can do in the calculator. So we're going to do e to the power of 5, and then I'm going to go ahead and make this divided by 9, and then I'll go back up into my numerator, and I'll do the minus 11. Just make sure we got that right. E to the 5th power minus 11 over 9. Sure enough, execute, and we get 15.268. 15.268. Okay. All right, now we're just going to try question number 13. Okay, question 13 here is another logarithmic equation, but this one is not ready to cancel the logarithm. You can see at the beginning here we have that 2. And I know by the properties of logarithm you may be tempted to put that as an exponent on what's on the inside, but that is a bad idea. Do not do what I just said. All we have to do here is just divide out the 2. If we just divide on the left by 2 and divide on the right by 2, we can just cancel that 2. That's way easier. So now we have log base 3 of 6x minus 17 is equal to 9 over 2. Now, you could do it as 9 over 2, but just, you can always try these fractions in the calculator, and this is a pretty simple one. It's just 4.5. So I think it's going to be easier to do this solution using it as 4.5 instead of 9 over 2. So that's 4.5. Now we want to cancel this log base 3, so we need to introduce an exponential base of 3. So we'll do 3 to the power of log base 3 of 6x minus 17, and that's on the left, equals 3 to the power of 4.5. Okay. Now the 3 to the power of log base 3, those are going to cancel each other out. Okay. And all we're going to have left is the 6x minus 17. So bring down the 6x minus 17, and that's equal to 3 to the power of 4.5. We're going to leave that in the exponential form because it has that 0.5 there. That could mess things up. So let's cancel things on the left side here. We got that minus 17, so we'll plus 17 to both sides. And now we'll have 6x is equal to 3 to the power of 4.5 plus 17. I'm going to move up over here where I have a little more space. 6x is equal to 3 to the power of 4.5 plus 17. Now we're going to divide on the left by 6, and we're going to divide on the right by 6. That'll cancel the 6, and all we have left now is x. And so our answer, well, before we put it in the calculator, is x is equal to 3 to the power of 4.5 plus 17, and then that whole thing is going to be over 6, which we will put into the calculator. So we're going to do 3 to the power of 4.5. Let's come out of the exponent there. I'm going to go ahead and hit the divided by, and I'm going to put the divided by 6 on the bottom. Then I'm going to go back up to the numerator, and that's, and then I'll handle that plus 17. So plus 17. So now we have 3 to the power of 4.5 plus 17, all divided by 6. And again, you can do these a little piece at a time. You don't have to do it the way I'm doing it. I'm going to hit execute, and the final answer is 26.216. So 26.216, and that is our answer. That is the solution for